Welcome to Spring LIB.
In the A part, we have to find out the dependency of amplitude with various quantities given. So the first is the time period, and we know the formula for time period is 2 pi into root of m upon k. Here you cannot find, this is a constant. There is no variable which represents amplitude. Hence, this is independent of A, therefore the value does not change. The second one is frequency. That is 1 upon t. 1 is a constant. It is only dependent on time period, and we have already told the time period doesn't change with respect to amplitude. Hence, frequency also doesn't change. The third is our angular frequency, and the formula we know that it is 2 pi f. 2 is a constant, pi is a constant that is only related to frequency, and we have already told that it is not dependent on amplitude. Hence, angular frequency is also independent of amplitude, hence doesn't change. So we have to understand the time period, frequency, and angular frequency. All the three quantities are not dependent on the amplitude. In the B part, we have been given energy, and we know the formula, that is E equal to half Ka squared, when x is equal to plus or minus A. Now, when A is half, that is A becomes A by 2, what will be the new E1? Half K A by 2 the whole square. That is half K A square upon 4, which is equal to E by 4. So, what do we understand by this? We understand that when A becomes A by 2, then E decreases by a factor of 4. So this is what happens when amplitude decreases by half, energy decreases by a factor of 4. Understood this much? So let's move on to the C part. In the C part, it's given V max. That is, we know the formula, that is omega into A. Omega we know 2 pi f into A. Okay, so V max 1, that is equals to 2 pi f A1, and V max 2 equal to 2 pi f A2. Now f doesn't change with respect to amplitude. Now since A2 equal to half A1, okay, since A2 is half A1, V max equal to V max 2 equal to 2 pi f half A1, that is equal to half V max 1. Because A2 is half of A1, V max will also be half of the maximum of the velocity of 1. Understood this much? Okay, so let's move on to the D part. D part, we have Vx, that is velocity is given by the formula plus or minus root of k upon m into root of a squared minus x squared. Now x equal to, it is given plus or minus a1 upon 4. Okay, so Vx becomes plus or minus root of k upon m into root of a square minus a square by 16, that is a1 square upon 16. Now there are two cases: original amplitude, that is v1x, that equal to plus or minus root of k upon m into root of a1 square minus a1 square upon 16. That is equal to plus or minus root of 15 upon 16 root of k upon m a1. Okay, this is with original amplitude. Now with reduced amplitude we have v2x, that will be plus or minus, this will be the same, root of k upon m. Here it will be a2 square minus a1 square upon 16. This remains same. This is x. Only amplitude is reduced. So this is a1 and this is a2. So that is equal to plus or minus root of k upon m into root of a1 upon 2 the whole square minus a1 square upon 16. So in this case, we are going to get v2x as plus or minus root of 3 upon 16 root of k by m a1. Now we have to, in order to compare both the quantities, what we are going to take the ratios. Okay, that is v1x upon v2x, that is equals to root of 15 upon 3, that is root 5. So what can we tell? That v2 equal to v1 root 5. What does it mean? It means that the speed of x, that the speed at this x is 1 by root 5 times as great. Okay, so we get v2 equal to v1 root x. This is how we find the relation, or we relate between two quantities. How are they related to each other? Understood this one? So now let's move on. To the E part of it. E part. So here we have the energy, that is U equal to half kx square. Because x is same, so U will also be the same. This is the potential energy. Now K equal to half mvx square. Now K1 equal to half mv1 v1x square, and K2 will be half m v2 x square. You have seen potential energy, because x is same, it remains same because it depends on the distance. Okay. Now, from this we understand that K2 equal to, we have got half m v2x the whole square, which is equal to half m v1x, half v1x root 5 the whole square. So we are getting half, right? V1 is upon. So it becomes 1 by 5 m v1 x the whole square, or we can write it as 1 by 5 into half m v1 x the whole square. If you see this, this is equal to k1. So you can write it as you can write k2 is equal to k1 upon 5. So this is the relation between both the energies. Have you understood this one? So we understand that by reducing A, the total energy, but doesn't affect the period and frequency. It affects the energy, but doesn't affect the period and the frequency.